All right, here is an explanation of 26 and 27 on the 16 polynomial review. So on 26, see if I can get it up there. So on 26, you have a 70-inch by 25-inch piece of metal. So here's my 70 and my 25. What size squares with integer side lengths should be cut out of each corner to build an open box with a maximum volume? So if you're going to take out an X from each corner, for example, a 1 by 1 or a 2 by 2, we're just going to say that this is X by X. So if this is the length of 70, that is going to become, right, the length of the box minus those two X's. The width of the box is 25 minus those two X's. And then the height of the box will be X. So you're folding those sides up, right? This is gone. And then when you fold on those dotted lines, this becomes the sides of the box. This becomes the sides of the box. So the new length of the box right here is going to be 70 minus 2x long, whatever x is, right? If this is x and if this is x, you're taking 70, subtracting off those two x's. If they're both 1, you're just taking 70 and subtracting 2, so you'd get 68. If this is 2 and this is 2, you're going to take 70 and subtract 4, so you'd have 66. And then this way, you're going to take 25 and subtract 2x. And then the height of the box, when you flip those sides up, is going to be x. So the volume is equal to the length times the width times the height. And so if you take a look at that in your y equals menu, 70 minus 2x, 25 minus 2x, and then times x, I might have to adjust my window quite a bit. Let's see, I'll say 0 to 70 because I know that it can't be more than that. And I don't know what our volume is going to be. 0 to maybe 10,000? I don't know. All right, so I can clearly see the maximum volume if I set up that, that window right there, right? And on my graph, these values have x values that we can't have because then there would be no box. So we need the x values that are actually between, let's see, if I cut 35 out of each side, I'd be cutting my whole side off. I could only actually cut, what, 12 on each side. So my window actually should have been from 0 to 12 for it to be feasible. All right, so to find that maximum, I go to second, calculate maximum, and I need to go to the left and to the right. So let's see, the left and the right, and that maximum occurs when x is about 5.6, 45, 44. So if I go to the nearest integer side, what I really should do is check my table of values at 5 and at 6 and see where the volume was the biggest. So I'm going to go to 5. So at 5, I was 4,500, but at 6, I'm 4,524. So that's why I said at 6 inches, I'm at 4,524. And then for 27, this is a function, x squared minus 8x plus 16. And I need to do the average rate of change between f of 6 and f of 9. So what I need is, I need the xy coordinates at 6 and at 9. So you could plug them in by hand. I'm just going to do them in my y equals menu here. So I'm plugging in x squared minus 8x plus 16. I'm going to my table and I'm looking up 6. So at 6, I'm at 4, 6 comma 4, and at 9, I'm at 25, 9 comma 25, and I'm going to do y2 minus y1 over x2 minus x1 to get my rate of change. So that would be 21 thirds, or just 7. So average rate of change between those 2 points is 7. What that means on this parabola, I don't know exactly where 6 is and at 9, but the slope between those 2 points is a slope of 7. Now they want you to find just the instantaneous rate of change at 6. So if this is 6, now I want the slope that just goes through that 1 point. So how can you find slope if you just have 1 point? You want to use 5.99 on one side of 6 and 6.01 on the other side of 6 to get the instantaneous rate of change. So I'm going to go back to my table setup at 6, count by 0.01, back to my table. These are the values I want to use. So at 5.99, 3.9601, at 6.01, 4.0401. So I'm going to subtract y2 minus y1 and divide by 0.02, because that minus that is 0.02. 4.0401 minus 3.9601. Hit enter, divide by 0.02. So I have a slope of 4. Does it make sense that this has less slope than this slope? Yeah, it looks less steep. So that would be the instantaneous rate of change on 27. Okay, and then you ask for page 187. I'm assuming you meant this problem right here. So we're finding a polynomial function that has these zeros and is third degree. So there's more than one answer, but it's going to be y equals x plus 2, because that would have a 0 at -2, times x minus 2, because that would have a 0 at 2, times x minus 3. And the reason they're telling you degree 3, because x times x times x, this is a cubic function. So I don't have to go any further. If they had wanted a 4th or a 5th degree function, I might have to square one of these factors to give it a higher power, but that's it. That is the answer to 42. And then 55. This time, they're giving you zeros and the multiplicity and the overall degree and a point on the graph. So this one's a little bit harder. So for 56, let's start out with our factors. So y equals, so if 0 is a 0, then you need x as a factor. Multiplicity of 1, so just x to the first power. -1, that gives us a factor of x plus 1, and it says make its multiplicity 2, so x plus 1 squared. And then 3 is a 0, so x minus 3, and they want you to make that multiplicity 2, so I'm going to square that factor. Is the overall degree 5? Let's just skim. Yep, x squared is x to the 5th overall. So they want us to go through 1 comma -48. So we need the a value, the stretch factor, to be a certain amount. So we're going to plug in 1 for all our x values and -48 for our y value and solve for a. So -48 equals a times 1. This would be 2 squared, which is 4. This would be -2 squared, which is also still 4. -2 squared is 4, right? This is the number 16, so I'm going to divide both sides by 16. Is 48 divided by 16 3? Yes. So 48 divided by -48 divided by 16 is -3. So that's my a value, my stretch value. So my final solution is -3x times x plus 1 squared times x minus 3 squared. And if you need more explanation than that, let me know.